Welcome to ME 160 Engineering Drawing, Part 6, Development, Section 1.3. Learning Objective 1.3. Be able to demonstrate the principle of auxiliary projection. Definition of auxiliary projection. Auxiliary projections are plans and elevations projected onto planes that are inclined to the principal and profile plane. That is, auxiliary projectors are inclined, neither vertical nor horizontal. Take a look at the three examples below. The principal plane vertical and horizontal are provided, and an auxiliary vertical plane is introduced. This plane is perpendicular to the horizontal plane, but inclined to the vertical plane. Second example, an auxiliary inclined plane is introduced. This is perpendicular to the vertical plane, but inclined to the horizontal plane. Third example, an auxiliary plane is introduced. This plane is inclined to both the vertical plane and the horizontal plane. That is a general issue of auxiliary projections. A projection of a plan onto a plane that is inclined at an angle less than 90 degrees to the principal or profile is called the first auxiliary elevation because it is projected from a plan. Take a look of a block. Example of a block. Here we have an example of a block, two views, the front view and the top view. If one considers the plan or top view, the following projectors: 1 in this direction, 2 in the other direction, 3 in that direction, 4 in this direction. The projectors here are all inclined, so the end results of these four projectors will yield the first auxiliary elevation because they are projections of a plan. Likewise, a projection of an elevation or front view onto a plane that is inclined at an angle less than 90 degrees to the principal or profile plane is called first auxiliary plan. Again, let's take a look at our block. Here we have the two views again, front view and top view. This time, let us consider the elevation or front view and consider the following projectors: 1, 2, 3, 4, all projecting the elevation. Any of these projectors will yield a first auxiliary plan because they are projectors of an elevation. Graphical adjacent views. An auxiliary view may be obtained by projecting an auxiliary projector, by applying our auxiliary projector from any one of two graphically adjacent views. Graphically adjacent views are two views that are mutual projectors of each other. Look at line AB. Now, here we have two views. The right side view, which is a vertical line on the left, and the front view, which is an inclined line now on the right. The left side view and the front view are graphical adjacent views because projecting the left side will produce the front view. Likewise, projecting the front view from the right must also yield the right side view on the left. Consider the top view now being provided as a horizontal line. Likewise, the top view and the front view are graphical adjacent views. Why? Because projecting the top view would produce the front view. However, the right side view and the top view are not graphical adjacent views. The right side view, which is on the left, and the top view, which is beneath, are not graphically adjacent views. Procedure of producing auxiliary projections. 1. Select the given view to be projected. Determine the auxiliary projector and label it as AP. This projector is neither horizontal or vertical. It is inclined. Select a mutual view of the given view in the first step and label that view as a mutual view MV. Indicate the mutual projector MP required to obtain the mutual view. Introduce a reference plane XY at right angles to MP and at a convenient location with respect to MV, which will enable us to determine positive and negative measurements from that reference plane. Step 6. Introduce another reference plane, X1, Y1, that is the image of XY reference plane, at right angles to AP. Obtain appropriate auxiliary projections of points on the given view by measuring their respective distances within the MV with respect to XY. Visibility of points, edges, and surfaces are based on the directions and closeness to AP. Example. Here we have an example of a block consisting of two views, the front view on top and the plan beneath. Now we intend to project by points, therefore we have to label all the points involved in this block. And we begin systematically by considering the base, which is a rectangle. And the base can be obtained from the top view. So we start labeling the corners from the top view. Now the base, first point, 1. 1 is within because it's the base and therefore not visible in the plan. However, 1 over there is in front of the top view. Therefore, it is going to be visible in the front view. 2 is the base corner 2, which is not visible in the top view. And because it is behind, that is the back, obviously will also not be visible in the front view, but will coincide with 1. Point 3, likewise, will be hidden, and in the front view will also be hidden within. And 4 will be hidden in the top view, but in the front view will be visible because it is in front so far as the top view is concerned. Labeling further, 5, which is vertically up of 1. Now that is going to be visible on the top view and likewise visible on the front view because it is in front. Then point 6, which is at the same height of 5 on top of 2, on the top view is going to be visible, therefore out of the box, but is behind the back. So it will not be seen in the front view, therefore within. 7. 7 is a point which coincides. One must obviously understand the object in the labeling of points. It's a point on the surface of the top of the object. However, it is behind, so it may not be visible on the front view. 8. 8 is here. From this, we know 8 is not visible on the top view because we know there is an edge directly above 8. Therefore, it's not. But in the front view, it will be visible. 9. 9 is directly above 8. So that's the top surface of the top view, and therefore going to be visible on the top view, and in the front, because 9 is in front, is going to be visible. Then 10. 10 is behind on the top view and visible, and on the front view is going to be visible. 11. 11 on the top view is visible, but on the front view is hidden because it's behind. And 12. 12 on the top view is visible, and on the front view it is also visible. Now let's see, we have our arrow direction inclined. Since this arrow direction is inclined, it means it's an auxiliary projector AP. And by the principle or steps involved, we have chosen the plan as to project. The result of this projection is going to be a first auxiliary elevation. Now we need a mutual view. The only mutual view provided here is the front view, therefore MV is the front view. The mutual projector is a projector of our given view such that the result is the mutual vector, and that is MP. Then we need to introduce our reference plane XY. XY is introduced here, and it is perpendicular to MP and at a convenient location passing through the points 1 and 4, so that in measuring distances from XY, all points above XY based on the vector MP are positive, whereas all points below XY based on the vector MP would be negative, but unfortunately there is none below. Now we introduce the second auxiliary, that's the reference plane X1, Y1, that is perpendicular to AP. Now we start off with our projection with taken by point 1. Point 1 projections. Now we go on to our mutual view and the distance from XY, and 1 is on the point XY, and therefore X1, Y1 must be coinciding with the 1 point over there. Then projector 2. Again, so far as XY is concerned, it's also 0 distance. Projector 3. That is also 0 distance. Projector 4 will give us a 0 distance. We go to 5. 5 goes along projector 1, but its distance from XY is positive because it's above XY. So we pick this perpendicular distance to XY and plot it on 5. 6. that is again the same positive distance. 7, that is the same positive distance. 8, that is the same positive distance. 9, the distance is about twice that above positive. Then 10, that is also about twice that. Then 11, that's about twice that. Then last 12, that's about twice that. Now we have our points identified, but to get our object, we need to draw the edges. And so far as drawing of edges are very important, visible edges are of paramount, and they are the first edges that are supposed to be drawn. And the visibility is related to the projector. So you could imagine yourself standing in the direction of AP. So in that position, the closest edge to you is the edge 1, 5. Therefore, that edge 1, 5 must be visible. So you draw the line 1, 5 being visible. Then from that point, looking in that direction, you have your left side where you can see 6 and 2, and you have your right side where you can see 8, 9, 4, and 12. So now, depending upon the direction, the edge you want to draw, here, one can move to see the right side, then from 5 to 8 will be visible. Then from 8 to 9 will be visible. Then 9 to 12 will be visible. Then 12 to 4 will be visible. Then 4 to 1, that is the base, will be visible. Then now considering the left of edge 1, 5, moving from 1, I can go to 2, that is the base, will be visible. Then from 2 to 6, that extreme edge will be visible. Then from 6 to 1, that will be visible. Now I can also consider edge 7, 10 will be visible. Then 10 can go up to 9 will be visible. So likewise, you can look at this and go through with that. And finally, you come to realize the only edge that is left would be the edge 3, 11, which is not visible. So we have now produced the drawings of that. And that view is the first auxiliary elevation because the projection was on a plan. Note, an auxiliary view projected from a principal view is called the first auxiliary. And the reference plane or the first auxiliary plane is denoted by x1, y1. An auxiliary view projected from a first auxiliary view is called second auxiliary, and its reference plane is denoted by x2, y2. Assignment 1. Determine the auxiliary projection of the object shown below. Here you have two views, the front view and the top view. The dimensions are given, and the projection is 30 degrees inclined to the horizontal from above on the plan. Please note, identify the name of the view that you have provided. Please show all points, show the visibilities of the various edges, and produce a neat drawing. Format of assignment. Provide your drawings on either A4 or A2. Keep the hard copy as evidence. Take a photo shot of your hard copy and save it under the file name ME160 6, then dash, not a point, neglect the point, dash 1, then space, then index number. Note, The 6 is the heading of the assignment, that is development. 1 is the number of the question number of the assignment. And send the soft copy through WhatsApp or email to the following: Joseph Avere as given and Bright Frimpong as given. Note, any other information will be directed to you through your general WhatsApp. So please pay attention to the general WhatsApp of the various groups. Thank you. End of part 1.